Today we're going to talk about average rate of change. The average rate of change is the change in Y, your change in the outputs, with respect to the change in your inputs. Algebraically, we could write this as the change in Y over the change in X, or Y2 minus Y1 over X2 minus X1. That little triangle there is a Greek letter, delta, which means change in. You'll see that symbol being used in mathematics and also your science studies. Let's take a look at this table and let's determine the average rate of change between 0 and 20. So we see here that our change in Y is from 0 to 16.7, and our change in X is from 0 to 20. If we write out the equation, we can have 16.7 minus 0 over 20 minus 0. Our rate of change would be 0.835. And we have to look at units too, because it's very important to always look at our units. And we see that what we're saying here is that for every 1 mile per hour increase in speed, the braking distance increases 0.835 feet. Let's take another look at this same table and find the average rate of change in braking distance from 20 miles per hour to 25 miles per hour. So again, we're going to look at the change in Y, 16.7 to 26.12, with respect to the change in X, so 20 to 25. And then we write the difference in the change in Y over the difference in the change in X. Once we subtract that, we find that we have 9.42 over 5. Our average rate of change in the braking distance from 20 miles per hour to 25 miles per hour is 1.884 feet per miles per hour. So we see here that we had a rate of change of 0.8, but from 20 to 25 we have a rate of change of 1.884. Again, for this second one, from 20 to 25, we would say for every 1 mile per hour increase in speed, the braking distance increases 1.884 feet. If we look at another one, we can find the average rate of change from 20 miles per hour to 30 miles per hour. So again, the average rate of change is the change in Y over the change in X. We'll look at these two. So we have 37.63 minus 16.7 over 30 minus 20. So our average rate of change is going to be 2.093 feet per mile per hour. So this would mean that for every mile per hour increase in speed, the braking distance increases 2.093 feet. So let's look at average rate of change graphically. Let's say we want to determine the average rate of change in cassette tape sales from 1990 to 1995. Well, we still want to find the change in Y with respect to the change in X. So we need to establish what our X1, Y1, and what our X2, Y2 are. So we need to find the data point that corresponds to 1990. Our graph shows on the Y-axis the cassette tape sales, and on the X-axis the years since 1990. So this point here, 0, and I kind of guesstimated it to be $370 million in sales. That point corresponds to 1990. And then I have to look at years since 1990. If I go over 5, that corresponds to 1995. So the point 340 would correspond to 1995. So I'm going to call my first point x1, y1, and my second one x2, y2. So if I plug that into our little rate of change formula, we're going to have 340 minus 370 over 5 minus 0. So I'll have negative 30 over 5, which is negative 6 millions of dollars per year. That means between 1990 and 1995, audio cassette tape sales decreased $6 million per year. Let's take a look at another one. Let's determine the average rate of change in cassette tape sales from 1995 to 2000. Again, we would have to find our data points. So in 1995, we said that that was 340, and I use 5 since it's 5 years past 1990. And then for the year 2000, that's 10 years past 1990. So I'm going to call that point 10150. Now I'll call my second data point x1, y1, just to kind of change things up a little bit. And my other data point x2, y2. And if I plug that into my little rate of change formula, I'm going to have 340 minus 150 over 5 minus 10. So here I'm going to have 190 over negative 5. And that's going to give me negative 38 millions of dollars per year. So what does that mean? It means between 1995 and 2000, audio cassette tapes decreased $38 million per year. So let's look at this graph. This shows total revenue in dollars with respect to quantity produced. So if we determine the average rate of change from 0 quantity produced to 100 quantity produced, we would have to find the average rate of change. At 0, our output is also 0, and I'm going to call that x1, y1. And at 100, I estimated that my output there was about 300. So, and I'm going to call that x2, y2. So if I put that in my formula, I'm going to have 300 minus 0 over 100 minus 0, which is going to be 300 over 100, which is 3. And this represents $3 in revenue for every quantity produced. So let's take a look at the average rate of change from 200 quantity produced to 500. So again, I'm going to have to find my data points. When there's 200 quantity produced, I see that my output is 600. And when there's 500 quantity produced, I see my output is 1500. So I'm going to put that into my formula. I'll have 1500 minus 600 over 500 minus 200. So I have 900 divided by 300, which again is $3 in revenue per quantity produced. So I can see here that in my two examples, the rate of change is the same. For this function, we could take any 2 points on the graph and we would find the rate of change to be the same. It would be 3, which represents $3 of revenue per quantity produced. We say that it has a constant rate of change. Linear functions have a constant rate of change. So when you have a graph and you find the average rate of change during different parts of the graph and they're the same, then you have a linear function. So let's take a look at a table of this and find the average rate of change. If we find the average rate of change between the first two data points, we can call the first one x1, y1, and the second one x2, y2. Then our rate of change would be 225 minus 0 over 3 minus 0. So we would get that the average rate of change is 75. And this would represent dollars per credit hour. So our average rate of change would be $75 per credit hour. If we look at finding the average rate of change between the second and third data points, we could call this x1, y1, and our next one x2, y2. And then when we have the average rate of change, we have 450 minus 225 over 6 minus 3. So we get 225 over 3, which again is $75, representing $75 per credit hour. If we find the average rate of change between the next two data points, again we could establish what x1, y1, and x2, y2 are, and find the average rate of change. And again, we would find that the average rate of change is $75 per credit hour. If we went and we calculated the next sets of data points and found the average rate of change there, we would also find that the rate of change is $75 per credit hour. So between all of my sets of points, my average rate of change is $75 per credit hour. Since the average rate of change is constant, we know that this is a linear function. And if we graph this data, our graph would be a line. So recapping here, the average rate of change is the change in y, the change in the outputs, with respect to the change in x, or change in the inputs. We know that a function is linear if it has a constant rate of change.